A. Anita, Assistant Professor of Chemistry from V.V. Vanniya Perumal College for Women. Let us get into the new module of chemical kinetics. What is chemical kinetics? The branch of physical chemistry which deals with the rate of a reactions is called a chemical kinetics. The rate means with reference to time. We all watch cricket shows. In that they display how much speed the ball hits the bat and how much the batter hits the ball and that it reaches the ground. In both of them, the speed of the ball is mentioned. How they measure the speed? Whether they travel along with the ball and measure the speed? No, they haven't done like this. But they measure the distance between that leaves the bowler and reaches the batsman. The distance traveled by the ball between the hand of the bowler, bat of the batsman is measured, and the time taken for that is also measured, and they measure the distance with the time they will get the speed at which the ball goes. Similarly, the distance traveled by the ball after hitting the ball and it reaches the ground, that divided by the time will gives the batsman hits the ball, that gives the speed of the ball, that is displayed in the cricket stadium. Similarly, the chemical reactions, the speed of the chemical reactions can also be measured using the chemical kinetics. That is, the speed is called as the rate of a chemical reaction. For that, we have to measure the progress of the reaction and the time taken between the initial and the final state. The progress of the reaction with respect to the time will give the rate of a reaction. That is, the progress of the reaction can be measured either by decrease in the concentration of the reactants or by increase in the concentration of the reactants. That will give the rate of a reactions or otherwise the speed of the reaction. The study of the speed of the reactions is called as the chemical kinetics. The chemical kinetics not only involves the study of the rate and the rate laws, but also about what are the factors influencing the rate of a reaction, such as temperature, pressure, the concentration of the reactants or the products, and the catalysts, which all influence the rate of a reaction, and the mechanism involved in that also contributes to the study of the chemical kinetics. What are the steps involved in a reaction and which step is the slow step and which step is the fast step, and what are all the rate determining steps present in a chemical reactions. The study of all these things will include in the chemical kinetics. Before getting into it, we have to know what is rate of a reaction and what is called as the reaction rate. Consider a reaction, that is the conversion of the reactant A to the product B. Here, as the reaction proceeds, the concentration of the A goes on decreasing, whereas the concentration of B goes on increasing. The rate of change of concentration of the reactants or the products with respect to the time is called as the reaction rate. That is called as the rate of reaction. For a given reaction, the rate of a reaction may be equal to the rate of decrease of the concentration of the reactants or the rate of increase of the concentration of the products. That is, the rate of a reaction will be equal to the rate of disappearance of the reactants, that is A here, and the rate of appearance of B, that is the products here. The rate of a reaction is given as the D minus D concentration of A divided by D, whereas the term given within the bracket, square bracket, gives the concentration in terms of molality, that is mole per liter, molarity, where small d symbol here represents the small change, infinitesimally small change in the concentration. Negative sign indicates here the concentration of the reactants goes on decreasing, whereas in the product term, that is the increase in the concentration of the B is given as plus D concentration of B divided by dt. Here, the unit of rate will be given as the decrease for the concentration. We have to given as the concentration is expressed in terms of mole per liter, whereas with respect to time, that is concentration divided by time. Therefore, in the denominator term, the minute or the hour or the second. The smallest unit is second. For the maxified or the scaling up of the reaction in time scale, it will be in terms of minutes or in hours. For smaller or for the faster reactions, the rate of a reaction is measured in terms of minutes or milliseconds. Whereas the reaction which takes longer time, the rate of a reaction is measured in terms of hours. For that, the unit of the reaction rate will be given in terms mole per liter per hour. For a fastest reaction, the unit of a reaction is mole per liter per second. There are two types of rate determination can be done. One is the average time, the another one is called as the instantaneous rate. For the average, consider the conversion of carbon monoxide plus nitrogen dioxide gives carbon dioxide plus NO. Here the rate of a reaction can be expressed as the decrease in the concentration of the carbon monoxide or the rate of increase of the concentration of the carbon dioxide. Here the concentration of carbon monoxide versus time is given here. For the time t equal to 0 second, the concentration is given as 0.1 molar. For as the time proceeds, when the time increases from 0 to 10, the concentration of CO decreases from 0.1 to 0.067. Here there will be a decrease in about 0.033 moles. For the time gap of 10 to 12, the concentration is further decreased to 0.050, where the concentration decrease is only about 0.013. For the next 10 minutes, the rate of reaction getting slower. For the next 10 minutes, the reaction rate gets slower and slower. For this, the graph is plotted between the CO concentration versus time. Gradation in the concentration of CO versus time is not gradual. Initial time, the decrease in the concentration is high, whereas as time progresses or the time increases, the rate of decrease of the concentration of the reactants is very, very low. In that case, the average of the slopes will have to be taken, but the average will not be the same as that of the original rate. Here the rate of slope of a reaction at the initial state is 0.033. Whereas at the final state, the slope will be given as 0.007, that is 7 into 10 to the power minus 3 moles. But that will not be the same. So therefore, it is not ideal to take the average between these two irrelevant values. Therefore, the other term, the instantaneous rate of a reaction, has to be considered. For that, the time gap between the measuring of the concentration of the reactants has to be decreased. That is, for small variation of the time, we have to measure the concentration and then we have to plot a graph between them. Then the slope of the curve or the slope of the tangent of the curve has to be measured. That is measured in terms of instantaneous rate of a reaction. For this instantaneous rate of a reaction, the time gap or the interval of a reaction has to be made infinitesimally smaller. That is, the change in time should be nearer to 0. For every small changes, we have to measure the concentration and you have to plot a graph. From that, we have to concentration decreases, we have to draw a tangent. For that tangent, we have to take the slope. That slope value will give the accurate value of the rate of a reaction. Here, the concentration of CO versus time is plotted. Here, there will be a gradual decrease in the concentration of CO on progress of the time. This graph is called as the progression curve. How much the concentration of the reactants or products vary with respect to the time. That is, the decrease in the concentration of the reactants with respect to time for that instantaneous rate. That is, when the time gap is very small or infinitesimally small, then the slope of a reaction can be considered as the rate of a reaction. With this, we end this module. Before come to the end of a reaction, we have to consider what is the rate of a reaction. Always the rate of a reaction depends upon the concentration. That is, the rate of a reaction is directly proportional to the reactant concentration. That proportionality can be removed by using a constant. That constant is called as the proportionality constant. As it involves in the rate equation, this constant is called as the rate constant. The rate of a reaction for a bimolecular reactions, that is 2A plus B gives product. The rate of a reaction can be expressed as K, rate is equal to K into A raised to the power M and B raised to the power N. Here M and M need not to be the coefficient of the stoichiometric equation of the reactants. The stoichiometric ratio need not to be the coefficient above the concentration of the reactants. For example, in this table we have given the 2 molecules of N2O5 gives 4 molecules of NO2 plus oxygen. Here the rate is equal to N2O5. Here the stoichiometric ratio 2 is not mentioned in the power of the N2O5. That is, the rate reaction involves when the rate increases once with the increase in the concentration of or decrease in the concentration of N2O5. Whereas in the next case, hydrogen and iodine, it gives H2. Here the stoichiometric ratio is 1, 1. Here in this power is also raised to 1. Here the stoichiometric ratio is 2. Here the power is also raised to 2. In this case, H2N2, here is also it raised to. But in this case, if we write similar to this, we have to write N2O5 raised to the power 2. But this is not the case. When we measure the rate of reaction with respect to the concentration of the N2O5, when the concentration is reduced 1 times, then the rate of the reaction is also slower down by 1 time. If the concentration of the N2O5 is reduced to half, then the rate of a reaction is also reduced to the value of half. Therefore, the rate of a reaction is proportional only to the concentration of N2O5, now power 1, and not to the higher values. That indicates the rate law. Here, in the next class, how this powers can be arrived from the rate reaction and how it can be measured, that we will see it in the next class. With this, thank you.